to welcome Matt Shaw up to the stage. Matt is an experienced web developer focusing on developing modern web platforms using Amazon Web Services. Is Matt here? All right, great. Okay. Matt's experience spans from transforming older legacy systems to cutting-edge greenfield development. In 2020, he co-founded artist development microservices that playlist. Matt is currently also a senior consultant at Headstorm, a boutique consulting firm based in Dallas, Texas. When he is not writing code, you can find him in the woods hunting, fishing, or camping. Matt, welcome.
Thanks, Alex. Let's see. Yeah, I do.
It's this barrier. So.
Thanks. Yeah, I was actually camping a couple days before this in Kentucky, and that was the first day of snow this year. So that was fun. Yeah. But thanks a lot for the introduction, Alex. Cool. So super excited to be here today. Today I'm talking about event-driven services, and this is a keyword. Maybe you've had this experience that I've seen in about 1 million different Medium articles and blog sites and such, but I never had the chance to actually apply it in my day-to-day work. So when I finally did about a year ago, I kind of felt like I was late to the party, and I wanted to share some of my experience with that. But first, just a little bit about who I am. I'm Matt Shaw. That's my dog, Dan. I am based in Charlotte, Tennessee, which is not Charlotte, North Carolina. It's a little town about 45 minutes northwest of Nashville. My career so far has been kind of split into 2 different phases. And the first phase was working on older legacy systems, maintaining them and building stuff on top of them. If you've ever worked on something old, you know it's pretty heavy on the maintaining and not so much on the building. But I would characterize the second half with some more modern development. Kind of what kicked that off was what Alex mentioned. I just, with one of my friends, co-founded this little microservices deal, which just uses a small AI engine to match up Spotify artists with a Spotify playlist that they can pitch to. And I'm currently a senior consultant at Headstorm, which is a small boutique consulting firm in Dallas, and we are hiring. So what's my excuse for being late to the party? Well, like I said, the first half of my career I spent working on older stuff, and a lot of this stuff was very tightly coupled together. It was deployed in kind of older ways, like moving one file from one server to another, stuff like that. And so I basically just didn't have a chance to spend the time to implement a more modern, sophisticated architecture in these scenarios. But thankfully, lately, I have been able to work with a client who has allowed me to do this. And that's where most of my experience is going to come from. So the way I want to go through this is, first I'll present an overview just of the problem that we're trying to solve and frame event-driven services as the solution for that problem. I'd like to give some of my general experience, pluses, drawbacks, gotchas, etc., and also a case study of one solution that we designed in this way that seemed to work particularly well. And lastly, I want to make the case why this might become timely for other people who are maybe not developing solutions with this architecture or through this paradigm. So to start with kind of an overview, let's consider like the most basic possible web app that we could have. We've got a client, we've got a server. The client makes requests to the server, and eventually after some period of time receives a response. It's probably saying an HTTP request of some sort to a REST API that's on the server. But it's not so simple in real life. We have lots of clients, lots of different users using our web app. So we have a number of clients making a number of requests. And of course, the complexities can just multiply from there. We might have some services running on the back end, maybe like scheduled jobs running nightly to ingest some data, transform some data that's already there. But long story short, we'll have things that aren't clients also communicating with the server, jobs on the back end. And not only that, since we're basically having a bunch of short-lived connections between the client and the server, it's possible that the client might have to make multiple requests just to get the response that they're looking for. So say, for example, like a long-running task of some sort that might take several minutes, the client's going to have to poll over and over again to see the status of the task and eventually receive a response, download it. And these complexities tend to snowball, and they create a number of problems that I'm sure lots of y'all are familiar with. And a lot of these problems can be summed up in one characterization of the server, which is that it's monolithic. Some of these common problems that tend to pile up are, one, the platform has too much responsibility. And this is both in a material sense, like the server has resources that get stretched too thin. In a more abstract sense, the server has to know about the entire system. So say, for example, if you have an e-commerce store, a monolithic server is going to have to know everything about how the accounts API works, how to connect with the external payment system, all sorts of things. It's going to have to know it all. From a developer's standpoint, the code base is just going to get huge, and it's going to be impossible to navigate. I remember back in my Java days, there was in IntelliJ, you could do find usages. So a lot of times you'd be looking for like the culprit of a problem that you were seeing. And sometimes it would take 1 or 2 minutes. And during that whole time, I would just be filled with existential dread about all of the going through the code that I was going to have to be doing. And even worse was when like 10 child classes popped up and you just knew that you're not going to find where that function was being used and actually messing up. From a more DevOps perspective, the CI/CD pipelines that you're using to build and deploy this monolithic server are going to be less than ideal. I also remember a particular Jenkins build that took maybe 1.5 hours, 2 hours to build everything. And if something went wrong at the 1 hour mark, that was really bad. And especially when you didn't exactly know what was going on, you'd have to make one small change, rebuild it, wait another hour. You know, it was not easy to iterate on it rapidly. There is a common solution for a lot of these problems, which is just to break that server into a number of services that kind of divvy up the responsibilities that the monolith used to have. This solves a lot of the problems that we just described. As far as the platform having too much responsibility, we can scale these services horizontally pretty easily. If you're in the cloud, hopefully it's going to happen automatically. In a more abstract sense, each of the services has a clearly defined responsibility for what it's actually supposed to do. You might have a checkout service in your e-commerce store, an accounts service, and it just divvies up these abstract responsibilities a bit better. The code base can still get huge with these services, but I will say a plus is that just the way that you name the files and the fact that you have an accounts versus a checkout versus an analytic service or something, it's pretty easy to figure out where the code that you're looking for is. And when you actually get into that file, it's going to be a lot easier to read what's going on in there. As far as the CI/CD pipelines go, obviously if you have a number of services that you're trying to build and deploy, you only have to build and deploy the services that have actually changed. So if you make a change in the account service, you don't have to build and deploy the checkout API as well. So it makes iteration much faster there. But by splitting this monolith into a number of services, what we took for granted with the monolith was that each of the modules contained therein were going to be able to communicate with each other for the most part. We knew that the account API could talk to the checkout class, et cetera, et cetera. So what we need to do now is find a way for these services to communicate amongst each other. We could just handle it as if a client was talking to a server and just have REST APIs in between each of these services. But when you start doing that on a large scale, it can be hard to secure and maintain, like especially if we're considering the documentation that you would need to document how each of these REST APIs was going to work for, hundreds and hundreds of services. It's going to be very hard to generate that documentation, and it's going to be even harder for a developer to read it. We've also created an interesting relationship where in the monolithic server, everything knew about everything, which was a disadvantage to some extent, but it was also kind of an advantage because if the accounts API has to communicate with the checkout API, all the information about that is available within our build. But with a more service-oriented architecture, we might have, say a user checks out or something, we might have to have the checkout API go update something with the account API, something in the account service, something in the analytics service. And basically what happens is it ends up having to know about a lot of other stuff that hopefully, ideally, it shouldn't have to know about. We still have the issue of these connections are pretty short-lived because of the nature of REST APIs. So if you do have a long-running task that's occurring in one service, other services are going to have to pull that service over and over again to figure out what the status of the task is and eventually get the response. So you may be asking yourself, is there a solution? No, there's not. Presentation's over. No. Of course we have a solution, and that's basically just to consider adding a different type of communication into this relationship, which would be evented communication. And I think this HackerNoon image does a good job of illustrating the change in the relationship here. Obviously, first we had a client makes a request and gets a response from a server. But what can make things a lot easier and solve a lot of these problems that we have is if we consider generators over here on the left. I like to call them producers personally. What if we could just have a number of services thinking of themselves as producers? They agree to send a message to a distribution layer of some sort, usually a queue, and whatever consumer needs to know about when this thing happened, it can enter into a long-lived connection with our distribution layer and basically listen for any of these events to be happening. Oh yeah, animations, okay. Going back to our problems that we saw in between services, as far as the APIs being hard to secure and maintain, this is not so much the case when we consider events moving in between producers and consumers. Number one, because queues can be secured through a lot of cloud services like AWS has SQS, and they can be secured using things like IAM roles, so you can offload that responsibility to them. Also, this eliminates the need for documentation of all these unique APIs. Basically, all that the producer needs to know is that I want to send this bit of information to a queue, and the consumers need to know that I can expect an event of this particular shape. This also abstracts away some of the knowledge that that services have to have about each other. So if a producer is publishing a message to a queue, all it needs to know is where the queue is. It doesn't need to know about who's interested in it, how many other services are interested in it, where they're located, any of that stuff. All you have to do is publish a message to a queue, and all interested parties will be listening to that queue. Since this does create a long-lived connection between the distribution layer or the queue between the producer and the consumer, basically we can have the consumer is interested in the result of the long-running task, seeing a message to the producer, or even still using a REST API to kick it off, and just listening to a channel for or a queue for the results of that task. So we've eliminated a lot of unnecessary requests. So that's just kind of a general overview. Now we're talking about my experience being late to the party. Some big pluses that I've experienced is that when you break this code out from a monolithic server into services, again, the code is much more readable. It's a very pleasant experience to go into like Lambda console and read a service that's just, you know, maybe 30 lines long, as opposed to having to flip your monitor sideways and reading something giant. The services are also much easier to deploy than a monolithic server. We rely with my current client heavily on using the SAM cache, which basically means that anything that doesn't get updated in CloudFormation stack doesn't get deployed. So that makes deployment much, much quicker. I've also found services much easier to maintain, in no small part due to the fact that, again, the bits of code are just smaller and it's easier to find them within the code base. But another thing is that it's also much easier to read the logs of a service instead of having to sort through logs of, you know, maybe multiple instances of a giant monolithic server and just seeing a bunch of garbage that you're not interested in. You can see where you've logged things in your service code and find them in a relatively small log. As far as using events to communicate in between services, events are much easier to read than HTTP requests. Obviously, they dispose with a lot of formalities, such as headers and such, that that most HTTP requests have. And queues perform super well at scale. I've put hundreds of thousands of messages through SQS queues, and that is never the limiting factor. In fact, the limiting factor is almost always whatever REST API the service that's reacting to that message is trying to call. It's not all unicorns and roses, though. There are some drawbacks. I've found event logging to be a pain point for sure. Obviously, by the time that the event reaches its destination, whatever service that is, you can log that the event has been received and what it looks like when it gets there. But sometimes you want to see what's happening within the queue, and services like SQS don't have a solution for this. I've been told, I don't have experience with Kafka, but people who do have experience with it have told me that it solves that problem, but they also said it introduces a bunch of new baggage that SQS in particular doesn't have. Error handling is sometimes hard. I mean, it shouldn't be in theory. It may just be because of my lack of experience with it, but with queues, you have an extra layer of complexity where you have to consider stuff like redrive policies and dead letter queues and stuff like that. And sometimes you wish that you could just be dealing with like a catch block on your promise. Ordering in duplicates are definitely something to consider too. This is basically the cost of the high throughput that queues have. Sometimes you get things out of order and duplicates as well. And there's basically two ways around it, is that you can either make your code agnostic to ordering in duplicates, which is a pretty popular solution, or you can use something like a FIFO queue, but FIFO queues are more expensive than just a simple queue. I think the throughput is limited too, if I'm not mistaken. Just some gotchas that aren't necessarily drawbacks, but just things that I found while implementing solutions was that the code bases can still balloon. And of course, this is kind of a situation of the grass is always greener, because it never gets as bad as those monolithic servers that I was working on. But I am in the process of splitting a repo out, and where it should have been probably 2 repos before for my client right now. So the need for vigilance is not totally gone. Another fascinating one that baffled me for probably a few days was that messages can get lost with no record. This kind of goes back to logging being a pain point sometimes with SQS, is that sometimes you'll have an event and you'll have a consumer elsewhere and something goes wrong before the event is logged. And if you don't have a redrive policy or some safe checks in place, that event's just going to be gone forever. There's also kind of a tension in between what event-driven architecture is supposed to do and what it actually can do. So basically, you might find yourself in a situation where you wish you knew all of the resources that were consuming events from a queue, or all the producers that are sending messages there. And there's not a good solution for mapping this, but if you really think about it, that's also kind of the point. Like the consumers shouldn't know who the producers are. The producers shouldn't have to know who the consumers are, but I want to know. And it kind of goes to this last point, which is that the coupling is not always as loose as you may think. So obviously a big goal of this is to decouple services from each other. But a lot of times, probably the most common thing that you run into is you'll change the event shape from one producer, and you think that you've changed all of the consumers in such a way that they'll be able to handle that new event shape, but you might miss a couple. And since it's not always easy to map who's a producer and a consumer, it just compounds. So just as kind of a proof of concept and a proof that this actually worked for me, I'd like to present a little case study of an ETL solution that we've been working on with my current client. It's in UAT currently and going well. We had a few requirements here, which is basically we had these apps that we were deploying to different instances of the platform, and we needed each of these apps to ingest data from a different external data source. And like I said, since this is a SaaS company, we needed to be able to deploy this app across multiple instances of the platform that were deployed as tenants. So what we were able to do is we started with a ingestion step function. And for anyone who's not familiar with step functions, what they do is basically handle orchestrations of processes in between, usually lambdas, but you can use lots of different services within a step function. But long story short, they just orchestrate processes occurring on AWS. So we started with this ingestion step function. Basically what it was responsible for was actually interacting with the platform and putting the data that we received in there. So we started with the chunking service, knowing that we could potentially receive hundreds of thousands, millions of lines of data. We split them out into chunks. From there, we passed an array of chunks to the ingestion service, and Step Functions also has a cool feature where it's called a map, where you can basically use an array as input to a part of the step function, and it'll create parallel executions of lambdas for every member of that array. So basically each of these chunks was ingesting in parallel. We sent the results of this ingestion to a result service, which just tallied up some stuff like how many succeeded in ingesting, how many failed, did we get any user-facing error messages that we want to surface. And finally, we sent those results along to the result writer service, which actually wrote all that stuff to the platform. And we affectionately call this the right-hand side. And we had a number of left-hand sides that we were developing. Some of the APIs that we're connecting with are synchronous. Some of them are asynchronous. So for the synchronous ones, all we had to do was have a service that makes a request, passes along the response to the response handler, which then wrote all the data to an S3 bucket and sent a message to an ingest queue, basically saying we received, or we generated a file at this time, and here's the file key in S3. And we just had a gate in between the ingest queue and the ingestion step function, so that we could log a number of things and also filter any messages if needed in the future. we also had kind of an asynchronous version of this. So we made the request, we polled for it for X amount of time before we hit a timeout. And we did the same thing, basically handle the response, put something into S3, and send a message to the ingestion queue. And just as a cherry on top of everything, we added an error queue that any of these step functions could potentially write to. And the result writer service was a consumer of the error queue so that we could surface any extra platform errors or using facing errors that we needed to. So I guess the question you might be asking now is, why do I care about this now, especially if I'm not in a position where I'm currently working or developing in this paradigm. I've kind of noticed some trends within my current client and also just software development at large that I think make this particular concept timely and basically make it more likely that you may be encountering this sooner rather than later. Thinking back to our kind of client-server relationship, when we consider kind of from a business perspective what's going on, we have an app and we have some infrastructure. And the app is what the user uses, and it accesses some infrastructure to give the users what they want. But now what a lot of companies seem to be doing is building a platform that apps can be built on top of. And this is certainly the case with the client that I'm working with right now. Basically why the businesses a lot of time are interested in this is because it allows them to scale horizontally without a bunch of extra overhead. And I'm not talking about like infrastructure-wise, I'm talking about markets that they can basically expand into. I think a good example of this is Meta. A lot of people were very confused with what the rebrand was all about. But my theory is that this is exactly what they're doing. Before they had an app, which was Facebook, and they had some infrastructure which Facebook used. And I even remember hearing some stuff about like they built some internet infrastructure in different countries or paid for some phones for some people and stuff to use Facebook. But basically what they're trying to do is break into new markets because like Chris was saying, they need to be able to continuously grow. So what Meta has allowed them to do is basically create a platform, and on top of this platform, apps can be built, whether that be, I haven't kept up with all of them. Facebook is still one of the apps. I think they're developing some VR and AR apps on top of it, gaming apps as well. But again, this basically allows for horizontal expansion of the business without necessarily having to hire a bunch of new developers and such. And what I would argue is that this architecture is especially important when businesses try to do this, basically sell a platform instead of just an app. And this is because apps are the ultimate in decoupling. When you have an app that's trying to access the platform, it has to be completely decoupled from that because the whole point of the platform is that the app can't directly access the infrastructure. And thinking or developing in this paradigm facilitates that. Also, apps want to know when stuff happens on the platform. I mean, that's basically what they're interested in, is the information that is contained on the platform, and apps don't want to have to be polling the platform over and over again to get new states and figure out when stuff is happening. They also demand flexible performance. If you are opening up your platform for anybody to develop an app on, you're going to have a lot of customers and developers, and a lot of people you don't know their intentions or exactly what their app is doing, what kind of demands it has, and how consistent these demands are. So a more service-based architecture allows more flexible performance, which these apps demand. So I hope that was, I made a good case for that, for you to consider developing through this paradigm. Again, I'm Matt Shaw. Here's my work email and my personal email, and there is my my LinkedIn query URL if you have time to write that down. What do you think, Alex? We got some more time, or?
We got time for maybe like 1 or 2 questions.
Okay.
Questions for Matt. All right, we got one back here. Oops, I just turned it off.
Yeah. Have you found that when switching from monolithic to this event-based, I mean, I don't know how many servers and networks and so on you have, having to deal with like network blips where the network goes out for, you know, a few seconds or minutes, or a particular event server or something, you know, goes out for a few minutes, how you troubleshoot that, and how that changes from in the monolithic app. You wouldn't have those kind of issues. So you kind of have a slightly different kind of issues when you start distributing all those services.
Right. Yeah, absolutely. Thinking from the perspective of maybe a web app that's built on top of many different services, there's a lot of great orchestration tools to work with them. Stuff like Kubernetes is obviously one of them. It can deal with different services going down and get them back up quickly. I don't personally have experience with Kubernetes. What I do have experience with is all of the Elastic services that AWS offers. Stuff like Elastic Beanstalk can monitor server health and do some auto recovery and such. As far as like if a queue is going to go down or something, it's actually, I think it's a good case for queues because it doesn't really necessarily matter unless the response that you're waiting for is timely, right? Because those messages are still going to be present on the queue whenever the managed service comes back up, and whenever it comes back up, the messages are going to keep on going through the queue.
All right. Do we have one more? We could probably get one more in. Does somebody have a question over here?
Well, probably the most obvious one is just that a lot of companies don't want to spend the time up front to transform a more monolithic architecture to a more service-driven one. It's also difficult because of the nature of the monolithic server. It's not easy to extract like little bits of the functionality out into services if that's how it already is. I would definitely say that's one of the more daunting ones. And people who are using monolithic servers also don't tend to be on the cloud. And I would say the cloud makes stuff like AWS makes designing stuff this way much, much easier. So you're probably going to have to convince your company to put some architecture on the cloud as well.
All right. Hey, thanks so much, Matt. Great job today.
Thanks.
Appreciate it, man. Good job.
Thanks, Alex.